everybody, I'm Parsa, and today I'll be talking about medical centrifuges and how they are related to centripetal acceleration and view them in both inertial and non-inertial frames of reference. I'm going to first talk about the process of sedimentation, then I'll go over the forces acted on a blood sample in a medical centrifuge in both frames of reference. After that, I'll talk about the formula for centripetal acceleration and how it is related to a centrifuge, followed by a suggestion for improvement and the societal impact of a medical centrifuge. Firstly, let's talk about sedimentation. In the most simple definition, sedimentation is a process by which suspended particles settle out of a fluid. So for example, if you have a glass filled up with water and sand particles, after a few seconds they will all settle down at the bottom. Now normally sedimentation happens under the influence of gravity and is limited to its acceleration, but medical centrifuge uses centripetal acceleration instead of relying on gravitational acceleration to make the process of sedimentation in the blood a lot faster. So instead of taking several hours, this process can happen as fast as a couple minutes. Now, if you look at the free body diagram of a blood sample in a medical centrifuge in an inertial frame of reference, we can see that the gravity and normal force are exactly present and opposite of each other as usual. However, because the blood is moving in a circular motion inside the centrifuge, it is accelerating toward the center of this circular motion, and therefore it has a centripetal force acting upon it. Now, examining the blood sample in the non-inertial frame of reference, since the frame is accelerating itself, there is a fictitious force present that is equal in magnitude and opposite in direction to the centripetal force, called the centrifugal force, hence the name centrifuge. This fictitious force experienced by the blood sample results in a sedimentation and separation of plasma from the rest of the blood sample. Now, in the class, we learned about the centripetal acceleration formula, which is AC equal to 4 pi squared RF squared. And the centripetal force is essentially mass times centripetal acceleration. And based on the definition, the centrifugal force is equal in magnitude. As you can see in the picture of the centrifuge, the R value in the formula is the distance of the blood sample to the center of the circular path in the centrifuge. The M is the mass of the blood sample that is being centrifuged, and F, or frequency, is the number of times the blood sample completes a rotation along the circular path of the centrifuge in a second. So we can simply just plug these values into a formula and find the centripetal acceleration experienced by the blood sample and how it is far greater than gravitational acceleration. Now, an average centrifuge performs a blood centrifusion in a couple minutes and has a radius of 16 centimeters and a frequency of around 50 Hz. We can improve this by increasing the radius of the circular motion and increase the frequency in which the blood sample completes a rotation. From the formula, we can see the centripetal acceleration is directly proportional to both the radius and frequency, meaning that an increase in these two factors results in an increase in centripetal acceleration. The improved design can help in getting a blood report in a matter of seconds in case of an emergency when a patient just comes into the ICU and needs their blood analyzed. Centrifuges have major societal impacts through diagnostics. By separating blood into its components, they can identify conditions like diabetes, anemia, and they can also be crucial in forensics for identifying victims and criminals. Thank you.